The title of the talk, I guess this should give some context. I'm giving a talk at RubyConf in 2 days, so this is like a rough cut. So I totally appreciate you guys. Any feedback you might have afterwards, or even just listening and not going to sleep would be awesome. But so just to give some context, because the RubyConf audience isn't as focused as this, part of this is going to be talking through why certain monitoring things should happen or metrics things should happen. But I think what's good for this meetup is this really is not a Ruby-specific talk. It's a call to action to what I think the Ruby community needs to do better in the next year or more in terms of monitoring and instrumentation. So really, well, first, whatever your language of choice is, you could substitute in, and you would come away with basically the same message. So just out of curiosity, how many people run Ruby in production of some sort? OK, awesome. So this will be good then. So I'm Joseph Ruscio. I'm a co-founder and CTO at Librato. I organized this meetup with Nick, some of my colleagues. It's my first time speaking at it. And I love graphs. Everyone at Librato loves graphs. And so the first way I'm starting to talk is with a little bit of motivation. So it's like, OK, what's all this fuss about monitoring, particularly in the last year and a half, 2 years? Because if you're not really paying attention, you may say, we've been monitoring computers for decades, right? As long as there have been computers, we've been monitoring, haven't we? Like, how much memory am I using? How much disk space do I have left? So I think it's instructive to kind of look what's changed in the last 10 years. And so if you were delivering SaaS about 10 years ago, 2002, so your typical way you would go about doing that, I don't know if I can, that's not going to work. You get a seed round, a couple $1 million, and you'd need that because your upfront spend would be a lot, because you'd be racking and stacking servers, dedicated ops team. You'd probably have a very custom software stack you'd put together. Fast forward 10 years to, oh, I broke Keynet. OK. Fast forward 10 years, and now seed rounds, Y Combinator, companies like this are $20,000 order. Your infrastructure is all monthly burn, right? You fire up AWS. If you're lucky enough to have any ops people, you probably have one. Otherwise, it's probably just you and the guy sitting next to you who do ops. And you're building your product, your minimum viable product, out of open source software and external services. And so what does this tell us about like modern infrastructure? So the good thing is it's agile. What I mean by that is that because of things like cloud computing, you don't need that whole team. You can scale up. You can totally change your business model. You don't have to go buy a whole new rack of servers. The bad news is that it's ephemeral, right? So how many people run stuff on AWS? How many people of you slept well last night? Right, a couple of you probably did, but most of you probably didn't. And so where we're at is we have more powerful tools, but change is much more constant. Sorry, we have more powerful infrastructure. Change is much more constant. And we have what I like to say is worse tools. Like, I promise you, Google has the most amazing metrics monitoring capabilities, but that's only good in their custom-built stack, right? That's no good to any of us. So we're all out here trying to do as best we can with tools that are coming up. And focusing in, particularly on the change thing, I like to drill in then. The most important thing, I think, is continuous deployment, right? So how many people do continuous deployment? A couple? OK, that's good. That's good. Or close to continuous deployment. And so what's interesting is I firmly believe that that is the path to the future. You can get me after this. We can go through it. But I think in 10, 20, even fewer years, not doing continuous deployment will be the exception, right? And so a big part, because not only is your infrastructure ephemeral, but now your code is shipping multiple times a day, right? You need your continuous integration with your unit tests. You have your one-click deploys, feature flagging to kind of roll out some of those features to some people, not to others. But that's all prior to the ship kind of control. Once code is out in the wild, if you're changing the site multiple times a day, your monitoring and alerting are really the only tools you have to know when that change has caused a problem. And so I claim that the renaissance in monitoring is in large part driven by the move towards continuous deployment with cloud computing. And since we like to have data, I did a ridiculously unscientific Google trend search. What I thought was interesting, if you look for cloud monitoring and continuous deployment, it's an interesting correlation, at least, over the last couple of years. So if you subscribe to those theories, then the next question when you're trying to convince someone in your organization you need better monitoring is, well, what does that give me? So you can do things. Wow, that one's dark. This is a slide from Travis CI. There's a spike here, HTTP status codes. But you can see there was a deploy, there's a bug detected, they shipped it fixed. There's another bug that was sorted out. That's a little better. Anyone who has run a queuing system in production dreads this graph, but recognizes this graph. So this is a queue that got stuck and starts accruing unprocessed jobs. And also there's a deploy that fixes it and the queue starts to drain. So you can detect regressions. You can, if you are putting performance fixes out, you can validate that those actually worked. So here's a average latency graph that shows a deploy and then shows that the average latency is dropped by order 35 milliseconds on responses. You can also confirm that behavior you see in your metrics, you can correlate that those have come from the sources you think. So we have a periodic load here. This is a read request in a Cassandra ring. And it's hard to see the annotations. You may be able to see the purple flags, but that is showing a batch operation that's occurring periodically. So you can see that the spikes in read operations are corresponding to the batch op. You can detect changes in customer behavior. So in the leapocalypse, the leap second, this is a graph of malformed API requests coming from our users, or 400s, basically. So right after the leap second hit, we had a bunch of users whose code used in our API just flipped out and started sending us garbage. I think related to the JVM bug that got hit with that. So you can detect regressions with metrics. You can validate new hypotheses about your running code with metrics. You increase your resilience and tolerance to change with metrics. So this may be sounding familiar, this high-level set, right? So the biggest kind of very first high-level takeaway from my talk, if nothing else, is that I really like to push this concept that instrumentation of your running code is unit testing for ops, right? And we absolutely should not ship code without instrumentations. Like people today would not ship code without unit tests, libraries, applications, et cetera. And so the call to action, we should get to a place where people do not ship their code without instrumentation. And you say, OK, I'm a Rubyist now, if you put your Rubyist hat on. And I agree with you, Joe. So I'm going to go Google for Ruby monitoring. Like, let's see what the state of the Ruby monitoring union is. And you end up with this explosion of all kinds of different tools. I picked a mix up here. Basically, there are some tools up here I think are really awesome. There are some tools up here that I think are really not so awesome. And I'll leave an exercise up to you guys if you want to sift through it. But the takeaway here is I think what most people end up with, and the reason why we don't have a lot of instrumentation like we have unit tests, is that much like unit testing, instrumentation, or rather the consumption of metrics, the visualization, the analysis, is actually a fairly intensely personal decision, right? Particularly because there's a visual component. Like as human beings, we feel very strongly about the way that should happen. And so what we end up with, the anti-pattern you see is these monolithically integrated solutions you get. So if you Google, I'm not going to name any names, but if you go to GitHub and you Google like Ruby monitoring frameworks, you'll find all these frameworks that have some gem you install, and it pushes to an in-memory database like Redis or MongoDB, and then they've got a web server that talks to that thing, and it's all awesome as long as you just subscribe to their entire philosophy and how they think everything should work. And invariably, even if you do in part of it, you're going to find a bunch of things it doesn't do for you or they're missing, so you'll go get another one that does those things and another one, and you have all these silos that you can't correlate across. I mean, in practice, what you see if you query Rubyist, you definitely see, New Relic is an 800-pound gorilla. Most people use New Relic. You'll see some of those monolithic open source software frameworks, StatsD and Graphite, like Jordan was talking about. Librado services like ours you'll see. Oftentimes you'll see combinations of these. So I think with the goal of getting instrumentation to be as common as unit testing, you have to take a step back and we need to say, what's going on? Let's decompose the problem here, right? And so I like to think about it if in the Unix philosophy, right? If we break this up, we've got collection, aggregation of metrics like a statsd, storage of metrics like Librado or Graphite, analysis. And I think Jordan alluded to this. Like from a sysadmin perspective, you want tools, sharp tools that plug in together, right? And in this talk, because I'm talking mainly to Rubius, I'm focusing in on the collection. So how do we get, if the collection is instrumentation, how do we get people to do that comprehensively, right? So what did devs require? That they need concise primitives to add to their code, instrumentation primitives. They need minimal dependencies, right? The biggest problem with those monolithic solutions is they have all kinds of dependencies. You have to be running Redis. You need to know how to run Node.js in production. The actual instrumentation code itself needs to be fire and forget. If I'm writing a gem, I need to be able to put the instrumentation code in and have no worries about where it's going, whether it's to a log file or to JMX. And there has to be minimal performance impact. This is for monitoring production code. We can't have something like a profiler or like Valgrind that says, oh, well, you just run this and there's a 10x slowdown. What operations requires is it needs flexibility at all the other layers in that stack. So I need to be able to take your Ruby gem that has this instrumentation, and I need to be able to do whatever I want with those metrics. Whichever one of that big array of products, I need to be able to plug it into. So I need simple introspection of the metrics you've collected. I need a simple way to capture that and then push it to where I want. So our ideal instrumentation library, if we're focusing now just on the instrumentation that we want widely disseminated, has the primitives, captures the state that come through those primitives, provides access to it, and doesn't do anything else. It has no opinions on reporting, it has no opinions on storage, no opinions on visualization. And so the next question is, so where do we get started? So I was looking around and trying to find, ideally, and so this is, again, something now, if you're whatever language you're in, I think this applies, right? And so in Ruby, you could ideally, if you wave a magic wand in the standard library, you'd have something to say, oh, here's just this, it's in the Ruby standard library. But you have to have adoption typically before you have standardization. Who knows, maybe I'll get someone in the audience on Thursday. But barring that, there's this gem called metrics, which I think is actually pretty close. And so it has those primitives. It's thread safe with atomics, which is a Ruby implementation of compare and swap, so it's performant. And importantly, I think, is it mirrors, if anyone's heard of Coda-Hail metrics. So if you're substituting language in and you're in Java, go look at that right now. That's the equivalent. So it was inspired by that. And it's important, too, for polyglot shops. So Librado, we're a polyglot shop. We run Ruby in production, but a big part of our infrastructure runs on the JVM. So for us to have a common set of primitives that we can reason about the interaction between different components is really important. So taking metrics as an example, and the most important takeaway, too, is it doesn't have to be this gem, but something very close to this is, I think, ideal. So how do you instrument code? How do you count, right? The most basic thing is I want to count stuff. And so basically, there's just a counter. I can increment it and decrement it. So if in your gem or your app you need to count things, that's what you do. How do I track a rate? So it has this thing called a meter. And so what you do is anytime, I guess a rate is basically how many things per second, like how many requests per second, right? So the difference between a rate and a counter is primarily that you can't decrement rates. Like you're just tracking how many things happen. So here's an example of just some code that's tracking the number of 500s, 404s, et cetera, in a rack middleware. So we just create a meter, it's called, and we just mark. Basically it's just incrementing the rate counter. How do I track distributions, right? So if I want to know the distribution of, say, the content length of a response, right? And so it has something called a histogram. So what we do is we create the histogram, and then we just add a length to it. So basically, every time a request comes in, we can just say, hey, histogram, here's another content length. And what that thing's going to do is maintain for us a distribution of content lengths. How do I time something? So now this is really important. So I need to know what's my average request latency, for instance, or you'll see later, 95th percentile request latency. And so metrics has a concept of a timer, which basically just has two forms. So you can time a block. You can just wrap a block of code. Or you can explicitly create like a stopwatch, start it, do something, and stop it. And so second takeaway is that's it. Like this solution, for the people writing the code and the gems, that is literally all they need to know. If you want to time something, do this. If you want to count something, do this. If you're tracking a rate, do this. If you're tracking distribution, do this. And that's all the code they need. There are, of course, like edge cases, and you get more sophisticated. But for broad adoption, you can get a very long way with just that. OK, so now we're going to put our ops hat on, say, OK, well, that's fine. I've got the devs now. They've got religion. It's so easy. So how do I actually access this data and do what I want with it? So metrics maintains a registry, it's called, which is an in-memory store. So basically, every time you're calling one of those commands, it reaches into this in-memory store and updates the state associated. So it increments the counters or the histograms. It's thread safe, and it provides for simple iteration. So now, on our consuming side, so now you're the ops guys, so you want to push this wherever you want. There's just a simple iterator through the metric, through the registry, which is thread safe, and it's double buffered, so there's no blocking metrics or anything. And you can just walk through you can introspect by just walking through every key that's been put in there by the code author. And based on the type, because these types expose to you different facets, do something with it. So right here is where you could push this all to a log file to get it into Logstash. If you're running JRuby, you could push it all to JMX, so you could use your tooling like JConsole, et cetera. You can push, there's reporters already for it for Librado, Graphite, and I believe for StatsD too. And then so next question is, how do I interpret it? OK, now I've got it out. So what are those facets? So a counter is very simple. It's an absolute count. A meter, and this is kind of where it gets cool, because I've tried to keep things very simple from the dev's perspective, but you'll see where the primitives built in here are actually pretty sophisticated. And so it's tracking 1 second rates. It's tracking an average rate, as you might imagine. But it's also tracking the 1, 5, and 15-minute trailing weighted moving average, right? So we'll get that smooth graph that Jordan had a picture of. And it's similar to the Unix load, right? I mean, if you're a sysadmin, you probably recognize 1, 5, 15. And you can pull a count, too, like a total count of events. Histograms, these are the distributions. So this pulls out, it's got statistics about the average, the min, the max, the variance, standard deviation. It has quantiles, so 95th percentile. This uses a pretty intense mathematical method called reservoir sampling. And I guess I should have mentioned that, too, in the performance. Most of your statistics textbooks, you'll talk about, oh, this is how you get percentiles. But those are all what's called stationary analysis, where you have a set of data, let's say 100 samples or 200 samples, and you walk through it and calculate. For your production instrumentation, you need to deal with streaming data, right? So in a long-running piece of code, you could have millions or even billions of samples coming through this distribution. So you can't just keep all of them, and when you say, I want the 95th percentile, I can't just say, well, I'll go look in my terabytes of memory where I'm keeping all the samples and pick the top 5%. So it uses something called reservoir sampling to handle that and do a pretty decent job. So the timer, which in the simplest case is just literally wrapping a block of code with a timing operation, actually includes both a histogram and a meter. So you can track both the distribution of your timing, so you can get things like 95th percentiles, as well as rates. So you get your rates for free. So if you're tracking the timing of requests, you also get to track your request rate from the same data structure. And so in closing, in my sprint through this, most important thing is instrumentation is as important as unit tests in a continuous deployment scenario. So as you look to the future, I think that's something that should be kept in mind. We need, regardless of language, definitely for Ruby, but regardless of language, we need some way, if we're going to say you have to instrument all your code, a simple way to do that that doesn't have any dependencies that would prevent people from doing that. And so in Ruby, the discussion right now that gem is going on, we're actually actively talking about how to really trim it down, because it actually, upon first inspection right now, even still, it looks kind of like one of those things. It's actually not clear that you can pull away the reporters and the other things and have just this core set of primitives. And so right now we're talking on the GitHub repo, if you're interested to get involved, about the best way to kind of hone that down and push this forward. Yeah, so any Any questions?
One thing that I think that most people get into is that once they get to this type of system and they drink the Kool-Aid, they want to put all the metrics and everything. Even at a relatively low infrastructure footprint, this becomes big data, to coin a term over time. The sensor data unfettered can become really large and unmanageable. So I think that as the sophistication goes down, a lot of people haven't solved the storage and visualization technique, but a lot of people have solved the instrumentation technique. How do you think that the people are going to deal with that in the future?
Well, so I think the decomposition is actually really important for that, because you're right, like at scale, and especially the more things you monitor, it does become a big data problem, and that's part of the reason why we founded the company we did. But so breaking it up so you don't actually have to care about that, and you're not locked into whether you don't like RRD or you don't like OpenTSDB, but you can switch without changing your instrumentation, I think is really important. And the other thing, kind of similar to JMX, so I think it's interesting to look at JMX because there's a lot of things it got right. I think it's really cool that you can take a tool written, so like in the last year and a half like ours, and hook it up to JMX instrumentation that was written 15 years ago is a success. And there's a lot of problems with it too, but one of the things that does, one of the things metrics does is you only have to pull the data out that you want, right? So within a given process, your footprint for any one of these instrumentation is literally just the space to continue, like for a counter, it's an integer, right? So if you're not, my suspicion if this is adopted is there'll be kind of at least two levels. There'll be the kind of high level as the gem author, the domain expert, you're like, okay, if you're operating this, these are the 4 things you really have to care about. And it'll go all the way down to, you only care about these if you're writing code in this gem, right? These are your debug metrics. And so I think in production, at least the number you're pulling out should be smaller. Okay, cool. Oh.
Do you know of similar projects for other languages?
So Coda released the metrics library actually at GitHub's CodeConf a little under 2 years ago, I guess a year and a half ago. I believe there were like immediate spurts, basically because that was like a polyglot conference. Like literally the next day there were like 4 or 5, but I think a lot of them are tailed off, and it's also, there's some actually pretty sophisticated stuff inside too. So I think some people kind of started and then didn't want to read the paper on reservoir sampling or something like that, right? Which is understandable. So what I would look for, I would Google for Coda metrics in whatever your language of choice is and see what you come up with. I'd definitely be interested. You could ping the meetup group if you find some.
Okay. So I feel like a lot of the stuff that we talked about, or you talked about here, is kind of stuff that applies very well to a single process or a single box. But when you get to aggregation, like how does reservoir sampling work? Or how do absolute counters work when you have to start summing them up across boxes?
Mm-hmm.
I'm not saying you aren't solving problems. I'm just asking.
Yeah, no, it's a very good question. I mean, so part of the nice thing about the decomposition is I can just kind of hand wave and say, I'm not talking about aggregation. But most of these types are actually all set up to combine. I mean, if you think about like counts, rates, even timings, right? The distributions is you can. I'll have to actually check specifically on the reservoir sampling, but I don't see any way it wouldn't support this if it's in use in a thing like this. But generally speaking, these primitives, the results can be combined across processes, like aggregated up, because like your distribution, your mean and your min, and so when you add 2 of them, is your max bigger than my max? Whichever one's bigger we take, whichever min is smaller we take. Internally, I'm probably tracking the total sum and the number of samples, so we just slam those together, we can get a new mean. So for most of these, what you need is something like StatsD, we support this in our back end, but something that you can say, hey, this is the level of aggregation I need. And actually the other thing that's important is because of even in process, the reporting is so broken out, the snippet I had that walks the registry, you can actually run that in like a background thread, right? And if you want, like do multiple snapshots, pull them together and push them up every n minutes. I think he's doing it in Redis for some of the reporters right now, actually. So you can do that too. The thread can put it in Redis and something else can pull it out. So. All right, so then I guess just meetup related announcements since I'm already up here. If anybody has anything cool they want to talk about, I mean basically like Nick and I just pound the streets begging people to talk. We've got lots of cool venues. I think the guys at Heroku want to have us over at their space as soon as we get some speakers. So if you or anyone you know has cool stuff to talk about, and the purview is really wide, like I appreciate Jordan putting a metric spin, but I totally think logging is super important for monitoring, right? So anything, visualization, analysis, logging, someone needs to talk about, just get in touch with Nick or me and we'll set something up. So thanks, guys.